Okay, section 5.8, special right triangles. So we've looked at right triangles and used the Pythagorean theorem to find missing sides. Now we're going to look at even more special ones. So let's get started. Consider this square. It says find the diagonal of the square. I'm going to draw in the diagonal. We know that squares have all equal sides, so if one side is 7, they're all 7. We also know that squares have 90-degree angles. So if I draw my diagonal, then this angle here is 45 degrees, and this angle here is 45 degrees, and this is where we get our first special triangle, a 45, 45, 90-degree triangle, describing the angles of the triangle. We're going to find the hypotenuse of this triangle. Hypotenuse is the side across from 90 by using the Pythagorean theorem, a squared plus b squared equals c squared. So we have 7 squared plus 7 squared equals x squared. 49 plus 49 equals x squared. 98 equals x squared. And I can take the square root of 98. And in the past, we have taken the square root and used our calculator to find a decimal. I'm going to show you another way to simplify a square root. To simplify a square root, we break this down into the factors. Well, I know that 98 is 49 times 2. So I could write the square root of 98 as the square root of 49 times the square root of 2. The square root of 49 is 7 times the square root of 2. And I could multiply that out on my calculator, 7 times the square root of 2, to get an answer. In fact, why don't I do that? My calculator. Be patient with me while I open up my calculator. So I can do the square root of 98 and get a decimal, or I can do 7 times the square root of 2 and I get the same decimal. So today we're going to be looking for patterns, and we see then, maybe I can keep we see that this hypotenuse is the longest side of the triangle, and it's going to be 9.9. And we did 7 times the square root of 2. You'll notice that the 7 comes from the side length, and the square root of 2, we're multiplying by a factor of the square root of 2. I'd like you to pause the video now and try to find x in all of these pictures. All right, if you did this, you would find that in a right triangle, if you did the Pythagorean theorem and you simplified your square root, you would get 2 square root of 2. Or, on your calculator, 2.8. This one you would get 3 square root of 2. This one you would get 5 square root of 2. And this one, x would be 6, because we're given the hypotenuse is 6 square root of 2. So you'll notice this pattern that the hypotenuse is always longer by a factor of the square root of 2. And that is not a coincidence. That's a pattern that happens every time you have an isosceles right triangle or a 45, 45, 90 triangle. So try these ones without the Pythagorean theorem and see if you can guess the pattern or use the pattern. Pause the video now, try it on your own. This one is 16 square root 2. These are both 25. This one would be 7.5 square root 2, and this one would be 14. So here is your pattern. If you're trying to find a leg, you take the hypotenuse and divide it by the square root of 2, because a leg is shorter. To make it shorter, we're going to divide. To find the hypotenuse, you are going to multiply by the square root of 2. Another way you can think of these problems is that all 45, 45, 90 triangles are similar to this one by angle. And so you can set up a proportion, and I'll show you how to do that in the first example. Find the value of x in simplest radical form. Okay, so this triangle is similar to the triangle, the most basic one, where each side is 1 and the hypotenuse is square root of 2. So I can set up a proportion. 8 matches 1, so 8 over 1 equals x over the square root of 2, because those are both the hypotenuse. And now we can cross multiply. X equals 8 times the square root of 2. And this will be true for any 45, 45, 90 triangles. All right, we can do set it up the same way. So this is similar to the triangle 1, 1, square root of 2. But this time, 5 matches up with square root of 2, because those are both the hypotenuse. And x would match up with 1. So if I want to find x, I need to do 5 divided by the square root of 2. To find a leg, you divide by the square root of 2. A leg is shorter than 5. So we can find our calculator. I can do 5 divided by the square root of 2, and I get x equals 3.5. Or it's okay to leave it like that. All right, let's try this one. Remember, it's similar to the triangle 1, 1, square root of 2. Set up your proportion. 10 square root 2 matches 1, because they're both legs, and x matches the square root of 2. So I can cross multiply. X equals 10 square root of 2 times the square root of 2. Square root of 2 times the square root of 2 would be the square root of 4. And the square root of 4 is 2. And 10 times 2 is 20. So our hypotenuse is 20. Or you're welcome to use your calculator. 10 square root of 2 times the square root of 2. Oops. You get 20. Either way. Try this one. It's similar to 1, 1, square root of 2. So I can do 16. 16 matches the hypotenuse, square root of 2. X matches 1. So x equals 16 divided by the square root of 2. X equals 11.3. And x should be shorter than 16, right? Because it's a leg, not a hypotenuse. All right, try side 1 of your worksheet. Thanks for watching.